Hey, so in this video I want to introduce abstract and concrete classes. We'll start off with the abstract classes. An abstract class is a generalized base class that cannot be instantiated. Right, so we're going to try and prevent this class from being instantiated. I have two examples here. Let's say we have some class called shape. That is very abstract, right? Because what does that mean? Is it a line? Is it a triangle? Is it a circle? And if you have a line or a circle class, those are more concrete classes that you can instantiate, whereas again a shape class is more abstract. Another example is a character class. That is also abstract. What does that mean? Is it a player character? Is it an enemy such as a zombie or a soldier or something like that? In this diagram, shape is an abstract class, and then we derive two concrete classes from that, square and circle. The shape class may provide template functions that we don't implement in the abstract class, but that we go and implement and override in the derived concrete classes that we can go and instantiate. So again, we want to prevent instantiation of the shape class, the abstract class, but we can instantiate square or circle classes because those are not abstract. In this next diagram, we have the abstract class character again. Let's say we derive from that, but we create two more abstract classes with even more boilerplate or template functions that you can later on actually override and implement in more concrete derived classes. So we have player character and enemy character, and those are also abstract classes, meaning we want to prevent the instantiation of the character class, the player character class, and the enemy character class because those are abstract. But then we create concrete classes that we can instantiate from those abstract classes. For player character, these team-based games typically have some sort of medic that heals other characters, or maybe some tank character that can take and dish out a lot of damage. And we can derive concrete classes from the enemy characters such as zombies or the level boss. Each one of the concrete classes will override and implement the functionality as laid out by template functionality from the abstract classes, and they may also add specialized functionality. Now, how do we specify a class to be abstract, or how do we make a class abstract? Well, that is where pure virtual functions come in. Pure virtual member functions are template or abstract functions that do not require definitions and is used to make classes abstract. Now, derived classes that you intend to instantiate, or in other words concrete classes, and we'll talk about that in more detail shortly, must override and define all pure virtual functions. We have the declaration syntax for a pure virtual function. It's going to be virtual, so we have virtual, the return type, the function name, the parentheses, but you'll notice the weird thing with this declaration is it ends off with an assignment, so the equals symbol and 0 followed by the semicolon. So that is a pure virtual function declaration. So an abstract class is a generalized base class that cannot be instantiated, and the compiler is going to enforce the rule that it cannot be instantiated if the class has at least one pure virtual member function. And also, if you think about it for a second, if you have no public constructors, right, if you make your constructor protected or private, then you'll also get an error if you try and instantiate your class. And a quick summary on the differences between abstract classes and concrete classes. An abstract class is a generalized base class that cannot be instantiated. It encapsulates common features and is used in classification and organization. And you need to have at least one pure virtual member function or no public constructors for the class to be abstract, whereas a concrete class can be instantiated. As we've seen, your concrete class can derive from some abstract class, and in that case you must override and define all pure virtual member functions that are inherited from an abstract base class. So the pure virtual member function declarations that are in the abstract classes are just templates for what you expect to eventually implement in your concrete classes. So you can think for a second what's going to happen if you derive from some abstract base class, but you do not override and define the pure virtual member functions. Well, what's going to happen is that class is also going to be an abstract class. For it to be a concrete class, you must override and define all pure virtual member functions that are inherited from the abstract base class. A quick example on the constructor in this class entity, I have a public constructor, and then I just have some toString function which is going to print out entity toString. And then in main, I construct entity. So I instantiate entity, I do entity toString, and if I build and run that, we get entity toString as we would expect. What happens is entity gets constructed successfully, and then we do entity.toString, so this function will get called successfully. But what happens if I move this constructor? I'll just press and hold Alt and use my arrow keys, my down arrow, and I can move it to a protected section or the private section. Already you'll see a red squiggly. The constructor is inaccessible. So if you try and build and run that, you'll get an error. Entity cannot access protected member. And you'll get the same type of error if you move this to the private section. Just Ctrl B to build that, and you'll get the same error. This is one way that you can prevent the instantiation of a class, but typically you don't even provide constructors for your abstract classes because they are abstract and not meant to be constructed anyway. So instead you'll be using pure virtual functions for the most part. In this next example I have an abstract class, so I call the class abstract as well, and then in the public section I have this pure virtual function, so it's virtual void toString. It is pure virtual because I have this equals symbol followed by 0 and the semicolon. This is a pure virtual function declaration. Then I have a concrete class which publicly derives from the abstract class. Remember, a concrete class is a class that we actually want to instantiate, so this must override and implement, or in other words define, the pure virtual functions that it inherits. In this case the toString function, so we override that and we do cout concrete toString. Construct the object C, which is a concrete object, and I do c.toString. This builds and runs fine and we get concrete toString printed out. Now what happens if I try and instantiate the abstract class? I do abstract A, so I try and construct A which is of type abstract. Ctrl B to build that. And we get this error, abstract cannot instantiate an abstract class. Whether we try and instantiate an object of type abstract on the stack or on the heap right here, so I have a pointer to an abstract, and I try and allocate an object of type abstract on the heap, in both cases we'll get an error. So I'll just comment that out. And if you try and build this with a pointer, you'll also get an error. Cannot instantiate abstract class. But what we can do is, as we've seen in previous videos, we can have a pointer to a base class. In this case the base class is abstract. Then we can allocate a derived object on the heap. In this case concrete derives from the abstract class. And this will work fine. So now we can do abstract pointer toString, and if I build around that, that'll work fine. It'll print out concrete toString. Remember, the concrete type is an abstract type because it publicly derives from abstract. Even though abstract is an abstract class, in other words it has pure virtual functions, it's fine, we can still have pointers to that, and then you can assign the address of derived concrete classes to that. But again, if you try and allocate objects of a abstract class on the stack or on the heap, you'll get an error. So in this way we can still use pointers to the base class, that is if the base class is abstract, and we can have an array of pointers to that abstract base class, just as we've done in previous examples, and then those pointers can point to objects allocated on the heap that are concrete. A few final notes before we wrap up this video. You might have been wondering if we have a const function, so we have virtual void toString, we want this to be const because a toString typically does not modify the state of an object. Well, you simply do it like this. You have const, and then the 0 assignment is going to follow that. So you do your prototype of your function first, and then you follow that by this 0 assignment. So the assignment operator, the equals symbol, 0, and then the semicolon because this is a declaration. And then here you will have const followed by override. Build around that and that works fine. I mentioned that if you make use of virtual functions, then you also want a virtual destructor. Let's look at how the virtual destructor is going to work with an abstract class. You do virtual and then the destructor. So we're going to actually define the destructor. In the concrete class, we don't actually have to provide one because the compiler generated one is going to work fine. And it will be virtual by default as well. Now what you do not want to do is, don't try and make your destructors pure virtual by doing this. Simply define them like that, and what we can do is so I have a destructor for the abstract class and I have a destructor for the concrete class. And actually in main I don't go and deallocate whatever abstract point is pointing at. So I have to go and fix that. Okay, so we want to deallocate whatever abstract pointer is pointing at. And if I build a run now, it will do the concrete toString, it will call the concrete destructor and then the abstract destructor as well. So as you can see, you do not make your destructors pure virtual, nor your constructors, because you don't even make your constructors virtual to begin with. Another thing I'd like to note before we wrap up is that not every member function in an abstract class must be pure virtual. For the class to be abstract, we only need one pure virtual function, as we have it here. So we can do abstract pointer hello, build a run, and that will work fine. The concrete classes will inherit those functions.